Measuring the impact of early 2025 AI on experienced open source developer productivity. We conducted a randomized controlled trial, an RCT. I love. Apparently, they're going to say the word RTC or RCT so much that they need to pre-qualify it with an acronym or an initialism to understand how early 2025 AI tools affect the productivity of experienced open source developers working on their own repository. Surprisingly, we find that when developers use AI tools, they take 19% longer than without. AI makes them slower. We view this result as a snapshot of early 2025 capabilities in one relevant settings. As these systems continue to rapidly evolve, we plan to on continuing to use this methodology to help estimate AI acceleration from AI R&D automation. So I am very curious about this whole situation. The hard part of what they're saying is that unless if their sample size was very, very large, it's really hard to have some sort of A/B test, meaning that you can't really have an A/B test because you can't like say fix the same bug with AI and without AI. That's not really an available option. And so there's no control, right? Like the control is a bit unusual. Let's see how long these papers are. Okay, the paper is super duper long, so we'll have to kind of come in here and do a little bit of referencing in here because I'm actually very curious about this. Against experts' forecast and developer self-reports, early 2025 AI slows down experienced open source developers. In this RCT, randomized controlled trial, 16 developers with moderate AI experience complete 246 tasks in a large complex projects on which they have an average of 5 years experience. Prior experience, or 5 years of prior experience. Okay, so 16 developers, unfortunately, is also a really low number. Now, one could argue that the hard part is like, what am I even looking at? Speed? I'm not sure what speed is. What is baseline? How do they have baseline? How do they have all this? So let's try to see if we can look inside of here to understand what does zero mean? Because zero has to have a meaning such that this has a meaning and then this has a meaning, right? It's a little bit difficult to understand this. Okay, so let's go like this. Let's see. Against, where's my search? Wait, why is it not grabbing that? Against expert. Oh, expert. My bad. Software development is an important part of the modern economy and a key domain. Dude, I'm tired of reading high school papers. To reduce the inferential gap between measurements of AI capabilities and real-world impact, one can measure the impact of AI systems in real-world settings. Field experiments. Existing fields experiments aim at measuring AI's impact on software development, measure outcomes like number of added lines of code or number of tasks completed. Okay, so now we're starting to understand at least what does this mean right here, right? However, AI systems can affect these outcomes without productivity actually increasing. For example, code can be more verbose but functionally equivalent. A task can be broken up into multiple smaller tasks without the total amount of work changing, making it a challenge to interpret these results. This is actually a really great call out. I do like this call out. What they're saying is that you can imagine that if you're just measuring, say, lines of code, what does that incentivize? Well, that incentivizes more lines of code. More lines of code does not necessarily mean more features or more. It does not have any indication whether it's good or bad. It just simply means more lines of code. Also, if you take a task that, say, somebody would reasonably create, and then they take that task and break it into several subtasks, it doesn't mean that, oh, well, this person completed 5 tasks for this person completed 1. The idea, right? This is now we're getting into t-shirt sizes. Was that a medium? Was that a small? What was it, right? It becomes very kind of funny. All right. Experts and study participants, experienced open source contributors, substantially overestimate how much AI assistance will speed up developers. Tasks take 19% more time when study participants can use AI tools like Cursor Pro. See Appendix D for details on speed up percentages and confidence interval methodology. Okay, I actually let's just jump down to that because that's what we're looking at. For each issue I, we observe the realized completion time T sub I is greater than 0, a binary treatment flag AI sub I is within the set of 0 to 1. The developer's ex-ante forecast of how long the task takes without AI denote by T sub I no AI is greater than 0. If we estimate a log linear model, so the log of T of task I, alpha plus beta multiplied by AI sub I plus, okay. So I can't really envision what the hell that means. Okay, via ordinary test squares and report homoscedastic standard errors. Random assignment of AI guarantees consistency of B for, let's see, our beta hat for beta, What are they trying to say here? Okay, well, I'm actually like, I'm literally too stupid to understand this, but can I throw this in? Can I throw this in a nice, can I throw this in AI? What are they trying to say? The problem is I can't quite understand what they're attempting to say because I don't understand how that equation is derived. I can't visualize what it actually means. All right, Super Grok, tell me, what does that mean? They're looking at how using AI versus not using AI affects the time taken to completion task. Okay, how long the task takes, whether or not AI was used, they're all in the zero. BT, no AI, the developer forecast of how long the task would take them if they didn't use AI, an estimate made before knowing, okay. The regression model, this one right here, they predicted the, let's see, the log of actual completion time, a constant term, intercept, okay, measures the effect of using AI, adjusts for the expected task difficulty via the log forecast time without AI, some random noise. Okay, why include this one? Because harder tasks take longer, and this forecast is a proxy for difficulty. Including it makes the model more accurate and powerful, doesn't bias the estimate of beta because the forecast was collected before AI was assigned. So it wasn't influenced by AI, whether AI was used. What beta tell you? Thanks to randomness, let's see, assessment of AI usage. B is an unbiased estimate of the causal effect of using AI on log completion time. How much faster or slower things go when using AI, controlling for task difficulty. They're using a regression to figure out if the AI makes developers faster, controlling for how hard the task seemed at the start. Because AI was randomly assigned, they can say that the effect of B is causal. I think I understand what they're saying is that by including the estimation, they can effectively try to make sure that the task takes into account how hard someone effectively, says it is. Okay, so that's what they're saying is that with this is where people were. And so this is economics expert forecast, ML expert forecast, developer forecast during study, developer estimates after study, observed result. Nice. One obvious thing I have is why don't they have like Y Combinator's estimation, which would have something at 10 to 100x faster? Where's that option? I want that one. Okay, motivation. While coding and agentic benchmarks have proven useful for understanding AI capabilities, they are typically sacrifice realism for scale and efficiency. The tasks are self-contained, don't require prior context to understand, and use algorithmic evaluation that doesn't capture many important capabilities. These properties may lead to benchmarks to overestimate AI capabilities. This is really, really great. Like for those that ever followed the AGI ARC stuff, AGI ARC, right? This was like a whole thing that was going on, the ARC Prize being like, oh, we're doing this huge thing about how amazing AI is going to be. And so this is like how we identify who's the best. And this was the AGI tests, which were just like simple kind of little bit of like these type of logic puzzles going on here that when you look at them, they're actually pretty simple. Okay, here we go. We're going to try one. Let's see. We're going to try this task. Here we go. All right, example input. Example output. Oh man, this is looking hard. All right, how am I supposed to see this? Okay, I think I see this. Okay, I understand this. Okay, so what you have to do is you have to look for the things that fit together. So red to red, red to red, right? Side to side, side to side, wider top to top, wider top to top. Okay, got this. Boom, we're done. So we'd have to redetermine the output of this thing here. What is this? So there you go. There's this one. And then input is this. I'm not sure how you do the output being a 3x3 confuses me, right? I'm not exactly sure how I do an output of 3x3 here. I feel like I need to be able to, it's resize below. Oh, you can resize below. Oh, okay. Oh, you resize by doing all this. Oh, okay. I don't want to draw all this out, but I would do something that like this one fits right here. Where's the next one? This guy goes onto this green one. This green one goes onto this yellow one, right? You can kind of see how this would go, right? So it'd go blue, green, yellow, this, and then you'd have to figure out where the heck the rest of these things go, right? This little blue one goes right here. All right, there you go. What is this sorcery? Try by clicking. Clicking just means I'd have to go like this. Okay, I need 3. I need to create the blue object, right? And I'd have to go through and like draw out the blue. It's just a jigsaw puzzle. Yeah, this is just a jigsaw puzzle. All right. Yeah, I can change the size. I understand that I could go in here and go, okay, I want this thing to be, I don't know, a 20 by 20. Okay, cool. Now, but I still have to go in here and like draw the whole thing and be like, okay, the green one is like 1, 2, shoot. The green one is 1, 2, 3, 1, 2, 3, 1. This is what humans are really bad at, right? Okay, hey, caught. I'm bad at this. Prime failed the AGI test. I'm slow. Slow AF. All right, slow AF. Oh, can I copy? Oh, that's nice. Select. You can select. Oh, nice. Oh, you can select. Oh, that's cool. Copy. Paste. Oh, that's nice. Oh, okay, that does make things a little bit nicer. Can I control X? Can I control paste? Nope, can't. You can't control X. Okay, whatever. Whatever. Now make the pieces so they're rotated and reflected. Yeah, there you go. Whatever. I'm not AGI. I'm clearly not AGI. But anyways, that test, it does not capture that. Like, I think this thing rightly calls out. I think they're right on their motivation, which is that those type of tests don't actually reflect real world requirements, right? There's all sorts of other things. There's a context you need to understand. There's all sorts of, right? There's all sorts of other factors that come into it. You're not given perfect examples, perfect output, perfect example, perfect output, perfect example. How would you solve this, right? You're not given that. Instead, it's like you got a PM that comes in. It's like, dude, you need to make that like more user friendly. And then like somebody has to go, what the hell's more user friendly, right? Like you got to like think, what does that even mean, right? Like there's no nothing that you could just simply like do, you know? You have to like take all this information and attempt to do something. Right, so I think this is actually really good that they're trying to measure it in a different way. In the other direction, because benchmarks run without live human interaction, models may fail to complete tasks despite making substantial progress because of small bottlenecks that a human would fix during real usage. Also, a really good call out in the other direction that, you know, we can just fix things along the way and make it way better. This could cause us to underestimate model capabilities. Broadly, it can be difficult to directly translate benchmark scores into the impact of the wild. One reason we're interested in evaluating AI's impact in the wild is to better understand AI's impact on AI R&D itself, which may pose significant risks. For example, extreme rapid AI progress could lead to breakdowns in oversight or safeguards. Measuring the impact of AI on software developer productivity gives complementary evidence to benchmarks that is informative of AI's overall impact on AID, R&D, and acceleration. Is this that the whole like 2027 is going to be the end of the universe type thing? Or I don't know if you've seen that, but there's all these forecasts being like 2027. That's when the AI overlord that's when super intelligence touches down and we're all effed.
Give me the meat and give it to me raw.
All right, to directly measure the real-world impact of AI tools on software development, we recruited 16 experienced developers from large open-source repositories, averaging 22-plus stars and 1 million lines of code. Okay, so this is good. So these are very large tasks here. Okay. And that they've contributed for multiple years. Developer provides a list of real issues, 246, that would be valuable to the repository, bug fixes, features, and refactors that would normally be part of their regular work. Then we randomly assign each issue to either allow or disallow the use of AI while working on the issue. When AI is allowed, I wonder what they mean by AI. Do they simply mean, because they say Cursor Pro? Oh, man, so there's a whole bunch of questions I have with this test already. Like, there's a whole bunch of stuff that I think needs to be taken into account. We'll get there. Hold on. Let me just read what they have to say. Developers can use any tools they choose, primarily Cursor Pro with Claude 3, 5, 3, 7 Sonnet Frontier models at the time of the study. When disallowed, they worked without generative AI assistance. Developers completed these tasks, which averaged 2 hours each, while recording their screens, then self-report the total implementation time they needed. We paid developers $150 an hour as participation. Oh, so this is how... Dude, that's a great way to get developers. Hey, you know what's a great way to get developers? $150 an hour. What a great idea. Let's go. Hey, dude, you got some open source I can work on? Hey, bro, can I work on some open source? I could use that. Oops, took me 2,000% longer. Whoopsies, I accidentally worked 4,000 hours. I will literally suck dick for $150 an hour. Damn, that's crazy. That's crazy that you went straight to the dick sucking. You didn't even like start off with writing Java. Better than writing Java, that's for sure. I'd rather suck dick than write Java. Okay, slow down there. Okay, slow down. All right, here we go. Standard lib.js. JavaScript has a standard library? Dang, okay. I didn't realize that. jQuery. Oh, jQuery. Oh, yeah. Oh, my bad. Yeah, it's called... Sorry, I got stun locked so hard because I'm like, what's the... But, jQuery, that makes perfect sense. Okay. I do love this, that forecast with AI disallowed, forecast with AI allowed. They assume they're like an automatic assumption that you will just go faster by a huge percentage. Like, that's a good percentage faster. These are really good percentage fasters. All right. When developers are allowed to use AI tools, they took 19% longer to complete issues, a significant slowdown that goes against developer beliefs and expert forecasts. This gap between perception and reality is striking. Developers expected AI to speed them up by 24%, and even after experiencing the slowdown, they still believed AI had sped them up 20%. Let's pretend this is true for a second. Jobs are so back, people. I don't know if you know this, but man, the big beautiful bill had that R&D tax credit that was make it so that software developers are considered R&D expenses, which allows you to actually write off the taxes within a year as opposed to over the course of 5 years, which means that companies are going to be more likely to be able to hire people. Now, apparently, based on this study, they're going to actually be 19% slower than they were beforehand. Think about this for a second. Think about how amazing that's going to be. We got the big beautiful study. We got a big beautiful bill that apparently is going to help us software developers, and everyone's going to go slower. We're going to have so much Wing happening. It's not even, no. I understand that this is probably, right now I'm pretty skeptical about this whole thing, but I do love this idea, right? This is obviously only in the context of these developers. We don't know anything about these developers. Again, I will give my opinion, but I'm waiting for meat's back on the table. Dude, meat's back on the menu, boys. But I'm going to give my opinion here soon. I'm just trying to I'm trying to wait. I want to gather all the information first. But let's see. Below, we show we show the raw average developer forecast times and the observed implementation times. We can clearly see that developers take substantially longer when they are allowed to use AIs. Let's see. Average developer forecast versus times. Okay. AI disallowed, higher. AI forecast allowed. AI disallowed times, AI observed allowed times. I know this isn't a large sample. I know this is not a large sample, but this is so funny.
Can you believe some chatter asked me to send you bit for coitus? Crazy times. Kick.
Thanks to Fiasol. Dude, that's so funny that...
Give it to me raw.
I mean, okay, so I got to start giving some of my opinions here. I will say this. I do think that people who have AI feel more ambitious and potentially would take on larger tasks, assuming they can accomplish it easier due to the power of the AI. So maybe they're completing tasks that are harder because the harder is the implementation time, right? Now their forecast is completely wrong, right? This is very funny to see. Like what this says to me is that not using AI, they actually are pretty good at forecasting. This is actually a really crazy forecast going on right here, right? That's actually really amazing. Forecast versus actual time, assuming these are the exact same amount of time periods, like that's really cool. This is obviously super out of whack, but again, maybe they're also just simply doing tasks in which are larger than they'd normally do. It's kind of hard to measure, like what is, I wish I had a little bit more understanding because I kind of wish they would have had, what's it called? I kind of wish they would have had the AI allowed forecast also be mapped on top of like what they would have accomplished this without the AI assisted task and then see, are those two really close? Because maybe they AI, like on AI assisted tasks, or sorry, let me say this again. I'm totally using all the wrong words. I would love to be able to see their AI allowed forecasting to be mapped on top of what they forecasted if they couldn't use AI, because perhaps if they couldn't use AI would align much more closely to what the actual outcome is, meaning that the difference AI is making is not as big as we are perceiving, at least for these 16 developers. It's just that this difference is so striking, right? This difference is literally going to be, what, practically 30% more? Now try a 200-hour task. Yeah, I mean, again, there's also so much so much stuff. Disallowed versus allowed. Oh, I see it. Okay, people are saying why the test. Okay, so they actually are. They actually are doing that. Okay, so this is what's happening right here. Okay, well, actually, no, this is kind of confusing. I wish they wouldn't have done this. They should have broken this graph up a little bit more. I would love to be able to get my hands on this data. Because, okay, so what's happening here is ends 246. So there's 246 tasks. So of those 246 tasks, 110 of them were done without AI, and 136 were done with AI. That's 246, right? So this is the total estimation time of all of the tasks without AI. This is the total estimation time with all of the tasks with AI. This, of the tasks that were all done without AI, this is their total time. This, of all the tasks done with AI, is their total time. I would have loved to see, of the 136 tasks that were the ones that said they had AI, what was their non-AI forecast? Yeah, it's not average. Yeah, sorry. When I said average, I meant like, or sorry, when I said total, I meant this is like their average. You know what I was trying to say? It's not their total. It's not their sum, right? My bad. My fault. Incorrect language. Called me out. But you know what I was trying to say. You know what I was trying to say. Don't be pedantic, but also good on you for being pedantic. Okay, but I would love to see of these 136, what was their estimated time with AI disallowed. Now, the hard part is you can't do these tasks now without AI. Like, that's what I would love to see is I wish you could have got a second developer of equal familiarity with the repo, being able to work on the same tasks, and then being able to measure the difference between the two, right? Like, that would have been at least a lot more interesting of an observation. You know, one could argue, hey, well, you also have like experience and all this kind of stuff, right? And also, one thing that's not kind of in this little graph right here is what is the quality of these 136 tasks? How many of them had code that was modified within a week? How many of them led to a bug within the next 2 weeks? Like, were more people using the old-fashioned grandpa coding with their hand, causing more lines of code to be changed later on? Or were the people doing the AI caused more change? Like, there's some downstream or second-order effects that aren't measured with this graph at least. Let's see if maybe they address it later on. Because that's also just interesting. Because if you make a change and then that code is modified within a little bit of time, something about that says that your change wasn't sufficient, or your change was sufficient, new requirements came in. So it's hard to tell. All right, the paper might mention success later. Nice. Given both the importance of understanding AI capability and risk, the diversity of the perspectives of these topics, we feel it's important to forestall potential misunderstandings or overgeneralizations of our results. We list claims that we do not prove evidence for in Table 2. Okay, we do not provide evidence that AI systems do not currently speed up many or most software developers. True. This is about these specific ones. We do not claim that our developers or repositories represent a majority or plurality of software development work. All of this I can completely agree with. I'm glad that they make this claim because this is a very good and astute claim. AI systems do not speed up individuals or groups in domains other than software development. We only studied software development. Also good. AI systems in the near future will not speed up developers in our exact setting. Progress is difficult to predict, and there has been substantial AI progress over the past 5 years. Also, the correct answer. I don't know how to predict where software is going. To be honest, reading this article, 100% of these guys were fixing after AI anyways. I'm not sure. I have no idea. There are not ways of using existing AI systems more effectively to achieve positive speed up in our exact settings. Cursor does not sample many tokens from LLMs. It may not use optimal prompting, scaffolding, and domain repository-specific training, fine-tuning, few-shot learnings could yield a positive speed up. Yeah. So I like this. This was again, I love this breakdown saying, hey, we're not trying to make these really bold and we're not trying to make these bold claims. Instead, we're saying that, hey, this is just what it looks like from here. There's maybe many different ways to be able to make things, better. We investigate 20 potential factors that might explain the slowdown, finding evidence that 5 likely contributed to. Over-optimistic about AI usefulness. Developers forecast AI will decrease implementation time by 24%. Developers post-hoc estimate AI decrease implementation by 20%. High developer familiarity with repositories. Developers slow down more on issues they are more familiar with. Developers report that their experience makes it difficult for AI to help them. Developers average 5 years of experience and 1,500 commits on the repository. Large and complex repositories. Developers report AI performs worse in large and complex environments. Okay. Repository average 10 years old with 1.1 million lines of code. Lower AI reliability. Developers accept less than 44% of AI generations. Majority report making major changes to clean up AI code. 9% of the time spent reviewing cleaning up AI outputs. Implicit repository context. Developers report AI doesn't utilize implicit tacit knowledge or context. Okay. I'm going to make a different observation here. My different observation that could be a factor. One could potentially say that some of these developers, maybe they're a bit obstinate on using AI. And so perhaps that affects their ability to work as fast because they feel like they have to generate. They get upset, then they just rewrite. And so then there's like this whole kind of problem going on there. So there could potentially be some level of just like general angst against the AI generation that makes it so that they slow down. That perhaps isn't captured in this. I think people are bad at perceiving. That's one thing that it really says right here to me. That's a skill issue. To be honest, everything's a skill issue, right? I mean, I love saying skill issue as a joke, but reality is everything's a skill issue. Name one thing that's not a skill issue. If anyone does something, if anything is done and we say, hey, this wasn't done as good, it's a skill issue. It's just kind of, it's a cop out for having a real thought through it, right? Winning the lottery. It's winning a lottery is a skill issue. You planned on winning the lottery you played the lottery intentionally. That's a skill issue. Playing the lottery is a skill issue. I hate to bring that to you. You just happen to get a reward of a skill issue. That's the mistake. Anyways, all right, your inability to understand that not everything is a skill issue is a skill issue. Boom. Everything's a skill issue. Developers accept less than 44% of AI generation. That means they spent a lot of time generating than regenerating. Like, generation of changes aren't, they're not instantaneous, right? Majority report making major changes to clean up AI code. Again, I have this theory that, we spend a lot of time waiting for generation, which means that you will often lead to you doing other tasks or getting distracted, which adds more time, right? You don't have a tight loop. You have this kind of wider loop that maybe you get up to go you get up to go do something. You go do something else. You start reading something else. So you add a bunch of inefficiencies because you're not directly engaged in the activity, thus making it so that you are taking longer, but maybe you're not actually taking longer. There's also not the idea of concurrency of tasks. Like, how do I know that there's not a concurrency of tasks going on here? Which I think would be really interesting to measure, which is, okay, yes, you're using an AI, but now you could potentially be working on 3 bugs at the same time. So does that result in you actually having an overall speed up despite each one of the bugs taking longer than you would have been able to do by yourself hand coding it, right? There's a lot of questions that one could say. Also, at the end of the day, is the answer simply speed, or is there something about slowing down to speed up that actually makes more, that makes more sense? There's a lot of these questions that I feel like these things never ask or answer. We rule out many experimental artifacts. Developers used frontier models, complied with their treatment assignment, didn't differentially drop issues, dropping hard AI disallowed issues reduced the average AI disallowed difficulty, and submitted similar quality PRs with and without AI. The slowdown persisted across the different outcome measures, estimator methodologies, and many other subset/analysis of our data. See the paper for further details. Does this one go somewhere else? I do want to start looking through this paper. Maybe there's something cool in it. So how do we reconcile our results with an impressive AI benchmark scores? Well, again, I think I've been saying this from the beginning, and I think a lot of people say this on the internet. Why is every single model scoring 99% on all these benchmarks? Why is every model the greatest benchmark scorer of all time? Yet, every single one of these models having amazing benchmark scores, how come everybody says Claude 3.5 is horseshit now? Did it not score amazing on benchmarks? Were the benchmarks not incredible? Are you saying that these companies have a perverse incentive to train on the benchmarks or to attempt to look good on the benchmarks without actually being good? I refuse to believe that. Sam Altman is a gem to society and would never, ever do anything to be perceived as say, optimizing for commercial success. And anecdotal reports of AI helpfulness and widespread adoption. Okay, by the way, the reason why I partly think this is funny is yesterday I did receive a private message from an account with many thousands of followers, many, hundreds in fact. And he told me that I was leading you guys off a cliff. And I was just like, okay, well, this is a big account. Okay, what am I doing wrong? What did I do wrong? And he said, because of your opinion on AI. Then I said, I just don't like AI hype beasts. That's it. That's the response. I don't like AI hype beasts, right? I'm fine having normal opinions. Yeah, AI is kind of cool, but I mean, I don't think it's that great. I think there's things that are cool about it, depending on the project. I wrote Chessy, a game that we played with 5,000 people playing chess at the same time. That was pretty sweet. That was a lot of fun. I vibe coded it. Afterwards, I opened up the repository and looked at it, and it was literally the single worst code I've ever seen in my lifetime, and it was completely unmaintainable. So yeah, I kind of have a general opinion that it's still not great. You can't freeball it. You actually really do have to review it, and then you really just should rework the code every single time, but it can give you a nice direction. I honestly think that that's probably the best use of AI, is let AI solve a task, see how it solved the task, erase it, and then do it yourself. And that probably would give you a lot faster, a lot more insight into where the problem is, probably give you some ideas if you liked it or not, and then you could run pretty fast, and then you could still do it yourself. Alberta's great. Yeah, Alberta's really cool. I actually really appreciate Alberta quite a bit. Right? I appreciate most things she does. I think she's pretty funny. We should get her on the stand-up. What am I doing? I've never even once thought about being like, hey, Alberta, come on to the stand-up. What are you doing? Why aren't you on the stand-up? Right? Hey, taken together, evidence of these sources gives partially contradictory answers about the capabilities of AI agents to the usefully accomplish tasks or accelerate humans. The following table breaks down the sources of evidence and summarizes the state of our evidence from these sources. Note that this is not intended to be comprehensive. We mean to very roughly gesture at some salient, important differences. Man, now I actually want to, okay, now, dude, my brain's running right now. I actually want to try this test, and maybe I'm going to try this later on. What happened if I did the following? Hear me out here. I start building out a code base, okay? And then what I'll do is I'll use something like git work trees, or, I mean, really, I could just clone the repository twice, but imagine you could have git work trees, right? You could have git work trees. And I have my feature branch, and then I have master right here. The AI works on the master branch and goes in here and produces me a change set. I look at the change set, try to understand it, try to understand what it has done, and then I close it, never look at it again, and program the change I want to see here on the feature branch. Then I merge this back into master and then do the same thing over and over and over again. I'm curious how this would change my speed and my happiness with what code I have produced. Perhaps I've never tried doing this little loop right here. Perhaps this is something that I could actually find myself enjoying. Like, hey, this is like a nice, sophisticated suggestion engine. And then I take that suggestion engine, understand why they've come up to the conclusion. And then just like if I program something and throw it away, can I get somewhere kind of fast with that? All right, why does AI get the main branch? Oh, it's really, really simple why AI gets this one. Because I want AI to be up to date so I can have the feature branch in which I'm working off to the side. I then make the changes, and then I throw them back in master, update it, and then we retry this. Oh, 9 Levels of Hell by Dante. That's a great book. Let's see, task type. PRs from large, high-quality open source code bases. Okay, that's from dude, what does the R stand for again? I forgot what RTC. Randomized control trial. Okay, that's right. Randomized control trial. Benchmarks like SWE-bench verified, RE-bench, SWE-bench verified, open source PRs, authors written tests, re-bench, manually crafted AI, research problems with this one. Task type, anecdotes and widespread adoption, diverse. Okay, task definition. The user is satisfied. Code will pass review, including style testing and documentation requirements. Algorithmic scoring. Yep. Human users find code useful, potentially as throwaway, prototype, or single use. Yeah. Okay, so they're kind of just like doing this little comparison breakdown. I'm not sure if this is that fantastic here. Hold on, I got to turn off my alerts. There we go. All right. Models slow down humans on 20 minutes to 4 hours realistic coding tasks. Models often succeed at benchmark tasks that are very difficult for humans. Many people, although certainly not all, report finding AI very helpful for substantial software tasks, taking them greater than 1 hour across a wide range of applications. You know what I'm going to have to say here? I think there's another thing that's kind of important about this study. Notice who they're using. They're using open source developers that regularly contribute to million-line code base. This is probably going to fly in the face of what you probably hear when you look at anecdotal evidence. Because how do you get anecdotal evidence? You get anecdotal evidence probably from a place like Twitter, Reddit, Hacker News. What's the problem with that? Well, here you have what is like I would consider a great filtering. The filtering being, the people you're getting is very senior individuals, pretty much. Like one could argue that these are very senior individuals. The anecdotal evidence, you actually have no way to verify what their level is. Now, I will say that if you are new to coding, AI has to seem like the most magical thing in the universe because it makes you feel like you are a senior with experience. Your estimation of what it's like is going to be much different than someone over here. So perhaps, which is funny because these people were also estimating that they were going faster, but apparently they were going slower. I don't know if you can actually even deduce that from the study, but I do think that there's going to be a whole perception problem using anecdotal evidence from Twitter, Reddit, all these other places. Not only senior, but people who work on specific code bases for years and help shape it. Yes, these are very specific individuals that one would argue, are senior level, large code base, help shaping, really understand the code very, very well, right? Reconciling these different sources of evidence is difficult but important. And in part, by the way, I just completely ignore this middle one, right? I really don't think benchmarks are just like a great way right now. I just think you should purely ignore these. I think that the corrupt incentives, too easy to game, not great. I just don't think these are great. I think you should just completely ignore benchmarks. I'd rather trust anecdotal evidence over benchmarks, and I'd rather trust this over benchmarks. I think they provide nothing. Let's see. For example, we are interested in understanding model capabilities, both given maximal elicitation, sampling millions of tokens or tens/hundreds of attempts/trajectories for every problem, given standard common usage. However, some properties can make the results invalid for most important questions about real-world usefulness. For example, self-reports may be inaccurate and over-optimistic. Yeah, I mean, this is just, dude. You did not need AI for me to know that this was true, right? I mean, this is why we stopped doing, like, will this take you a day, and start going with t-shirt sizing. Like, is this a small, medium, or large tasks? Because we can't even get close to estimating as it is. So now you're adding a new tool that people are saying are going to speed you up a whole bunch. Of course, you're going to have probably some sort of weird bias and inability to measure how, like, well that's going to help you. It's kind of, if none of this should be surprising. I've never seen a task that I've completely underestimated how difficult it was. Here's me every single task. I could do that in an hour. 6 days later, man, that was a hard hour. Here a few of the broad categories of hypotheses for how these observations could be reconciled that seem most plausible to us. This is intended to be very simplified mental model. All right. Summaries of observed results. AI slows experienced open source developers and are randomized controlled trial, but demonstrates impressive benchmark scores and anecdotally useful. Okay, this is just a graph. Cool. Hypothesis 1. Our RTC underestimates capabilities. Benchmark results and anecdotes are basically correct, and there's some unknown methodological problem or property of our setting that are different from other important settings. Okay, reasonable. That's good to say, hey, they're actually wrong. Number 2. Benchmarks and anecdotes overestimate the capabilities. Okay, I feel like it's probably closer to this one because this feels more real than this one. Hypothesis 3, complementary evidence for different settings. Okay, or perhaps they're somewhere in the middle. Probably this is probably more real right here. Let's see, thinking that you can't do something is a big skill issue. Stopping midway is even bigger skill issue. Completing is a real big PP. Truing. I feel like this is probably the most realistic thing. Though the hard part is this is someone actually doing real work and we're measuring real work. So it's like, which one of these two is it? It's probably not this one, but maybe it is this one. Okay, actually, you know what? I could say this one. Maybe the problem with it, the reason why it could be this one is that the average person does not work in this code base. And so you are in a tar pit of methodology that's going to always prove it to be worse. That would be like your argument you could make on the other side, is that it's just too hard, and the thing you're testing against are just too hard of a problem for AIs today. So that's why anecdotes/benchmarks mismatch with your trial, which I think is a fair assessment. In these sketches, a red difference between the source of evidence and the true capability levels of the models represent measurement error or biases that cause the evidence to be misleading, while blue differences, i.e. the mixed scenario, represent valid differences in what different sources of evidence represent, if they are simply aiming to be different subsets of distribution of tasks. I will say this, that perception will always be wrong. People most certainly perceive things incorrect no matter what. So, like, that's why, again, anecdotes of people saying this is really fast or this is really slow, I think is super, super easy to overestimate. Like, even Copilot. There's times, by the way, it's also, I'm just super triggered that they did this in Excalidraw and then used that stupid line thing where they're like all uneven lines, and then even misdid this by a small amount, which just pisses me off. It's like, dude, you're already using a computer-assisted drawing program. Just make your lines straight, okay? Okay, just at least make the boxes on the same line. You're killing me, man. You are absolutely killing me. Just murdering. Like, look at this. This line hits the top slightly inside. Like, that's just, dude, just come on. Shift it down by a few pixels and it would just grate. All right. Oh my gosh. Oh my, I can't even remember what I was saying. Makes me itchy too. I know. I literally can't even remember what I was saying, but I will just say that whatever I was saying was brilliant and you guys loved it, and lots of Keck W's happened. Okay? The Kecks were flowing like the salmon of Capistrano. Using this framework, we consider evidence for and against various ways to reconcile these differences, different sources of evidence. For example, our randomized controlled trial results are less relevant in settings where you can sample hundreds or thousands of trajectories from models which our developers typically did not try. That makes sense. You couldn't do that, or else your time taken would be huge. It kecks on these nuts, damn. It also may be the case that there are strong learning effects for AI tools like Cursor that only appear after several hundreds hours of usage. Yes, that was another one of my questions, which was, what do the developers on average use? If you have let's say you have a bunch of developers that use Emacs, and now they're tossed into Cursor. I know a lot of people don't understand this, but for us who don't use VS Code-based tools, VS Code feels really confusing, right? It feels very hard to understand, and it feels very overwhelming, which can make you feel much slower. Now, I understand that people that use VS Code would find Emacs or Vim really confusing. VS Code is very easy, bro. It's not very easy, bro. The problem is, again, this is like literally selection bias at its finest, or anchor bias at its finest. If you use VS Code is easy. I would argue that I think Vim's easy. What do you mean? Like, this is simple, right? But I realize it's not simple. I realize that I am biased towards this. I've been using this for so long, it feels really, really simple. I don't have to memorize shortcuts, has nothing to do with the complexity or non-complexity of a product. Okay, so for you, I'm going to put you right here. So this is, whenever I see chat talk about these things, I realize that a lot of chat, you're right here on the bell curve. Stop being, okay. I don't have to learn keyboard shortcuts. Oh, damn, man. And it's so hard to, like, memorize a few things. Man, that shit's hard, dog. I get that. That's, like, the hardest part of developing is, like, memorizing, like, Control-S, like, dog, press the file button, press the save button, impossible. It's like, no, this is not, like, stop saying that. It's easy if you do it. You do it, like, 10 times, you have it memorized. That's not the hard part of development. That should have nothing to do with development. You shouldn't even think about those things. Vim is 100 keystrokes for one action again. So, Cryo, this is what again, I'm just going to say your IQ showing. And it's a little bit room temperature. Okay? What I am saying, and I'm trying to get you to understand this, okay? I'm trying to get you to understand this, is I had nothing to say. I didn't even say VS Code is bad. What I said is if you're used to this, that you can see right here, then this, coming up right here, wherever this feels more confusing. Okay? This feels more confusing because you are used to something that looks like this. This is called visual problems. So one thing, here's a good example. For those that feel why this is confusing, you know one reason why you feel like this is confusing? There's no tree on the side. You're used to seeing a tree all the time. And so there's this part of your brain that when you don't see the tree, you actually can't see the code. This is well documented. C.S. Lewis has this whole argument for why this happens, and he talked about this, 80 years ago with Ransome in Out of the Silent Planet. Ransome couldn't even recognize trees because the trees were formed differently. So you feel this great confusion when you see things that you aren't used to seeing. You actually cannot see them. So people who look at this actually have a hard time looking at the code because they don't have it shaped in the way they expect it to be. This is a very normal experience. That's why I'm saying it's very normal for somebody who doesn't use Cursor to find Cursor confusing. They're going to have a hard time reading the code. The code that they're reading is not actually as easy to see or process as it would be otherwise. Here's another great example that probably would be a better way to say this, is that who here does a bunch of reviewing of code on, say, GitHub or Stash or whatever platform, GitLab? You will often find that you can review code better in GitHub, in GitLab, in Stash, because that's what you do. When you go to that location, you go into review mode. You're used to looking at code with a certain critical eye. When you open up your editor, you look at it in a different way. You see code differently. You actually will program code. Like for all of us who've done this enough, you will program something and say, damn, I did a good job. You will take it, you will commit it, you will make a PR, you will look at your code in the PR and go, shit, dude, that looks so stupid. Why did I do it that way? This happens all the time. That's because perception changes in different environments, and this is totally normal behavior. This is one reason this was actually going to be like my big gotcha study moment, was this attack right here, which is that the people using these tools may not have used it beforehand, thus not have that feeling of familiarity, thus having some sort of slowdown that's unusual or ineffective in this environment that causes the study to be invalid. And maybe you need to measure this over the course of a year or 2 years as opposed to some small period of time. Cinema. All right. Anyways, I'm shocked that I have to have this. Okay. Anyone that just goes, VS Code is simple, all you're doing is saying, you're not actually saying anything. You're just saying, I am familiar with VS Code. I would say Vim is simple. All I'm saying is that I'm familiar with Vim. I'm not actually saying anything at all. In fact, I'm just saying vacuous words. That's it. That's all there is to it. Like, people have to understand these things. Some people, oh my gosh. You know what? I got to walk away for a second. That's it. I'm walking away. I had to give all my kids hugs. All right, our results also suggest that AI capabilities may be comparatively lower in settings with very high quality standards, or with many implicit requirements relating to documentation, testing coverage, linting, and formatting. That takes humans substantial time to learn. Okay, our results suggest that AI capabilities may be comparatively lower in settings with high quality standards. Okay. On the other hand, benchmarks may overestimate model capabilities by only measuring performance on well-scoped, algorithmically scored tasks. And we now have strong evidence that anecdotal reports / estimates of speedups can be very inaccurate. Yes, you have at least an example of it being inaccurate. No measurement method is perfect. The tasks people want AI systems to complete are diverse, complex, and difficult to rigorously study. These are meaningful trade-offs between methods, and it will continue to be important to develop and use diverse evaluation methodologies to form a more comprehensive picture of the current state of AI and where we are heading. You know what, honestly, I want to throw something out that I think would be amazing. Right now, there's a whole funding problem when it comes to open source. Whoever's producing this needs a lot more money, and they should be handing it out through open source contributions by funding people to do this thing over and over again with open source. Also, something that I don't see mentioned within this study is what language were they working on? Because there is most certainly, when I think of million-line code bases, I don't think of JavaScript. Yet, when I think of people who can say how fast and good the AI is, I think we can all generally agree that AI is best used with the JavaScripts, right? Can we at least agree that TypeScript / JavaScript tends to be the best usage? I think it was JavaScript. Are they all JavaScript or Python, right? Like there's kind of like, if you're using C++, I'm not really sure if it's actually as good. I have no idea. AI is best used with Python. No, I'm not sure if AI is best used with Python. I've seen that it's a lot of people talk about how good it is with JavaScript or TypeScript. C++ is terrible. Well, I'm saying, is the AI good at it? I agree with you. C++ is terrible, but is it the other way, right? All right, going forward, we're excited to run similar versions of the study in the future to track trends in speed up or slow down from AI, particularly as this evaluation methodology may be more difficult to game than benchmarks. Yes, it's actually impossible to game with this is the best part. Long as you can have someone that is sufficiently... Well, actually, there's like a whole set of problems, right? There's a whole set of problems that kind of go with this, which is, when you say AI, do you mean autocomplete or do you mean agents? I think that's very, very important. And then you're going to have two groups of people on the spectrum in which if you say, hey, don't use AI, you're going to have people that can complete tasks quickly versus, so this would be no AI, right? No AI. This would be AI, right?
Keep Bjarne Strostrup's name
and this is
out
time
of
taken.
Your goddamn mouth. Thank you for your attention to this matter.
I'll keep Bjarne's name out of my mouth. People who are familiar or people who do not program with AI will probably see something like this, is my assumption. And people who program with AI or with AI will probably see something like this, right? Without AI, with AI. So you probably will have this kind of like weird distribution in which you can't really say, because if you're only used to coding with AI and that's all you've been doing as far as autocomplete and agents go, like, how the hell are you going to be like, hey, turn off your AI? you're going to be so stuck with like the ability to process and do it well because you're going to be so used to this kind of offloading that you do on an AI. Like, right? That'd be very, very different. That'd be very, very difficult. And the inverse is probably true also. If you're used to just zoning in and just thinking about a problem and just typing and turning off everything else, and that's what you love, and then all of a sudden you have to use and wait for an agent, you could imagine, right? Anyways, just I think there's a lot to that probably is going to be really hard to measure. And so as going forward, like how do you measure that? I think your pool of available people that don't use AI regularly is going to shrink, and the people that do will grow, right? And I think that that's going to make it harder and harder to do, right? One of the repos in the study was standard lib for JS. If you want to check the list of repos, it's on page 45. Oh, nice. Okay, cool. Here. Mito, Haskell. Okay, well, I mean, one would assume that AI is pretty shitty at Haskell. But hey, this funded Haskell development, can we at least minimally agree that some of these may not be as good as other ones, right? White paper lang in white paper mentioned. I know, dude, this is crazy. White paper language in white paper is an insane thing. I don't even know what GHC is. What is GHC? Glasgow Haskell compiler? Oh, okay. See, like, again, I think that this, so for me, this actually really hurts the study more than it helps the study, if that makes sense, because I assume that AI is probably peak bad at Haskell, considering there is very little Haskell material out there, right? It's just like the AI is super bad at Elixir. There's not that much, Elixir out there, and so I can see that being so. It really does take the study and make me have much more questions about like the goodness of this study, if that makes sense. Scikit learn is Python, right? Yeah, it could be. AI is terrible at Zig. Yeah, AI is terrible at Zig. AI autocomplete's not that bad, right? Anyways, just interesting to see this. I would love to see them keep on doing this. And here's what I think would be very important is that you have a bunch of axes and you have a bunch of confounding factors, right? Confounding factor one is what tool of development are these people using with AI and without AI? Is there a huge conflict in tool usage, right? With AI and without AI. So are you using Vim for one, then Cursor for the other? That's going to cause a huge problem. But if they're using Zed for one and then Cursor for the other one, that could be like less of a confounding factor because Zed is at least VS Code-like. There's a lot of very similarities to it, so at least you're not like hurting the individual or slowing them down. So I think there's a big win there. Second, I do think you need to separate it out by language. I think that language is going to make a huge difference in a model and how it performs. So this is super, super important that you do that. I just cannot imagine that Haskell is not part of the reason why this is not doing that good. And then lastly, I think you also need to separate models out, right? Using model 3.7 versus 3.5. I found that model 3.7 to be really annoying to work with because it would overdo stuff, and I constantly had to fight it back and trim it down and say, okay, no, we can't make this change. No, we can't make this change. And that felt really painful. And so 3.7 was just not as successful of a model for me as 3.5 was. So therefore, model separation is also another dimension that's going to cause a huge confounding factor in all this. So you have familiarity, you have language, and model as three like axes that I think that they really need to figure out how to properly have, because there's a lot of like whoopsie daisies in here, if that makes sense. Anyways, there you go. That's all the things I have to say. Way overdue stuff is such a massive underestimate. Yeah. I actually, like, I'm genuinely, like, real talk, I'm very disappointed that they used Haskell. I'm, like, super disappointed that they used Haskell in this. I feel like if you're going to be fair with this test, you needed to use languages that were more popular. To have multiple Haskell repositories, I just feel like, if I were to try to make a paper if I were to try to make data to be the way I wanted it to, I would choose languages that I intentionally know aren't good at this, right? Like, I would totally do that. Like, if I was trying to bias a paper automatically. And so it makes me upset, right? It makes me upset. Anyways, love you. Bye-bye. The name is The Prime Gen.